All right, everybody. So we're going to look at how to find solutions to systems of functions. So in the past, you've done systems of equations where you just used maybe two linear equations and you tried to figure out when those would be equal. And remember, we talked about when you do two linear equations, there's one point where they're equal. So you're looking for an x and a y coordinate where the two functions are evaluated at the same point. And what we're going to talk about is the option of taking multiple functions, not just linear functions, and finding the solutions to those. So for example, you might have, maybe a parabola and a line where they cross twice, or you might do a parabola and a line where there's no solutions, or maybe a parabola and a line where they cross one time just right on its vertex, something like that. Or we could do any number of combinations. So we could do like a square root function with a parabola, which would have one solution. Or we could do an absolute value and a cube root function. So there's tons of different combinations, but we're just going to talk about how to find solutions to those. We're going to talk about how to find approximate solutions, and that's when we're going to allow you to use technology methods to do that. And then we're also going to talk about finding an exact solution algebraically, and that'll just be for basic functions, okay? So we're going to start by, I'm just going to go through an example. I'm going to use all three of these methods. I'm going to graph them and look for intersection points. I'm going to create a table of x and y values, or f of x. Remember, this is the same as y. And then I'm also going to solve for it algebraically by setting the two functions equal to each other. We will eventually, in class, we'll talk about how to use technology to make a table of x and y values. In this video, I'm just going to do the table by hand based off of my result from the graph. So very first thing, I'm going to do the three methods: graph, table, and algebraically. So first thing I'm going to do is graph both of these. And I went ahead and already put those into Desmos. So I've got them graphed, and what I did was I kind of already just stuck a point where it looked like they intersected. So remember, when we're doing this graphically, we're just kind of looking for an estimate. And what I would do is I would just kind of estimate where these are. So this one's at maybe 417, and this one's somewhere around -1 and 1, maybe 1, yeah, 1. I'll round that down. So what you're going to do on this one, when I ask you to do it by technology method, is you're just going to draw a quick sketch to show me what you found. So I'm just going to sketch in the parabola as well as the line, which intersects somewhere up here, and it kind of goes like this, and then I've got my 2 points of intersection, and then you're going to label those 2 points kind of with the estimates that we had said. So I'm actually going to go ahead and use a decimal, -1 and 1.4, and this one was something like, what did I say, 4 and maybe like 17 or something like that, right? Let me double check here. 17.5, I'm just going to go with 17 on this one. So maybe I should just go with 1 on this one then. Okay. All right, so then we're going to make a table. So I'm going to make my table with x, and then I'm going to put an output for f of x and an output for g of x. So I can just make one table and kind of compare back and forth. So let's try to find I'm just going to do one of the points. On your quiz, I'd ask you to do both, but we're just going to try to find one of them. So we're going to go by increments of like a half to try to figure out a little bit closer to this. So we want to use some inputs around -1. So let's do the input of -1.5, -1, and -0.5 maybe. Okay. So I'm going to put each of these into my function. So I'm going to do negative, so for f of x, I'd do 3 times -1.5 plus 5. So this would be 4.5. Don't laugh at me because I couldn't figure that out. 4.5 plus 5. So then f of x is 0.5 at that spot. And then we're also going to do x squared. So that would be 1.5 squared. .25, and I'd used a positive 1.5 just because it's the same thing. All right, so those are obviously not the same at that point. Let me make sure I did that right. Yep, 1.5 squared. All right. So then I'm going to evaluate it at -1. So I'm going to do -1 in for x in each function. So I'm going to get 2 here and 1 here. Okay, we're getting a little closer. Let's try -0.5. So I'm going to do 3 times -0.5 plus 5, and I'm going to do -0.5 squared. This is my f of x function and my g of x function. So for f of x, I'm going to do 3 times -1.5 would be -1.5. So that would be 3.5. And then g of x would be 0.5 squared, which I believe is 0.25. So this one's getting smaller, this one's getting bigger, and here these are pretty far apart, and so my best solution is somewhere around x of -1, okay? And then we're going to go ahead and try to find the actual solution here. And this is not always going to be an option because sometimes there are functions that are a little too complicated for us to solve algebraically, but we'll do this one because this is not too bad of one to try to solve. So what I'm going to do is I'm going to remember to solve a quadratic because really what we've got here is a linear equal to a quadratic. I set the two functions equal to each other to try to figure out what x value will make them both true. And then remember we talked about solving for 0, so I'm going to minus x squared from each side. So I'm going to get -x squared plus 3x plus 5 equals 0. And I'm pretty sure I'm not going to be able to do any factoring on this one because the only factors of 5 are 1 and 5, and those don't get me to 3. So I'm going to do the formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to do -3 plus or minus the square root of 3 squared minus 4 times -1 times 5 divided by 2 times -1. And simplify that down a little bit. I'm going to get the square root of 29 divided by -2. So I'm actually going to simplify that just one more. I'm going to do 3 plus or minus the square root of 29 divided by 2. So this would be our exact solution. To get a decimal approximation, I'm going to do 3 plus the square root of 29 and divide that by 2. That'd be 8.07. That doesn't seem right. That didn't come out anywhere close to what we had there. 3 plus square root of 29 divided by 2 equals 4.19. That seems better. .19. That's one x value, which is pretty close to this one that we got. And then my other x value would be 3 minus the square root of 29 divided by 2, -1.19. So also pretty darn close to the estimate that I came up with. And then of course you would also plug each of these into your function. So either one would work, x squared or 3x plus 5. X squared is pretty easy. I'm going to start by squaring the negative 1.19, and I'll get 1.4, which was my initial answer here, was 1.4, not 1, so that was pretty darn close that I got on that solution. And then I'm going to also square my 4.19, and I've got 4.19, I didn't square it, 17.55 or 0.56, I think, which is also pretty darn close to my original estimate. So there's my kind of exact answers, my algebraic steps to find those two solutions to my system. What I'd like you to do is to think of a system between this absolute value function and this linear function, and I want you to try all three methods before class on Thursday.